Welcome to our discussion of molecular and empirical formulas. In this video, we will define the molecular and empirical formulas, determine the molecular formula using molar mass ratios, and determine the empirical formula from percent mass. Molecular and empirical formulas are two different ways of representing the atomic structure of a compound. Molecular formulas are the formulas that give the total number of atoms of each element in a compound. For example, the molecular formula of hydrogen peroxide is H2O2. This tells us that in this compound we have 2 hydrogens and 2 oxygens. The molecular formula of glucose is C6H12O6, showing that we have 6 carbons, 12 hydrogens, and 6 oxygens per molecule of glucose. The empirical formula, on the other hand, just shows the simplest ratio of elements in a compound. It does not show the total number of atoms or elements. It simply shows the simplest ratio. So for example, our empirical formula for hydrogen peroxide can be simplified to HO because we have a ratio of 1 hydrogen to every 1 oxygen. For glucose, its empirical formula can be simplified to CH2O because the ratio of our carbons to hydrogens is a 1 to 2 to 1 ratio. Let's start by determining our molecular formula. So to find our molecular formula, first you need to find the molar mass of the empirical formula. And this formula, the empirical formula, will be given to you. Then you need to find the ratio between the molar masses by taking your molecular molar mass and dividing it by your empirical molar mass. Your molecular molar mass will also be given to you for these types of problems. And finally, multiply each element in the empirical formula by that ratio to get your molecular formula. Let's take a look at an example of how to find our molecular formula. In this example, the question states that dimethylglyoxine has an empirical formula of C2H4NO. If its molar mass is 116.1 grams per mole, what is the molecular formula? So in this example, they've given us the empirical formula and the molar mass of the molecular formula. So our first step states to find the molar mass of the empirical formula. So we take 12 for our carbon times 2, plus 1 for our hydrogen times 4, plus 14 plus 16 gives us 58 grams per mole for the molar mass of our empirical formula. Step 2 says to find the ratio between the molar masses by dividing our molecular molar mass by our empirical molar mass. Well, our molecular molar mass is 116.1, and our empirical molar mass is what we just found, 58. So 116.1 divided by 58 equals 2. And then finally, in step 3, we multiply each element in the empirical formula by that ratio. And our ratio is simply 2. So now we multiply C2H4NO by 2, and we get a molecular formula of C4H8N2O2. And we should always be able to simplify our molecular formula into our empirical formula as the lowest possible ratio. Now let's take a look at how we would find the empirical formula. Typically for these types of questions, they're going to give you the mass percent for each element within the compound. In other words, they're going to tell you what percent of the total molecule's mass each particular element within that compound makes up. So the very first thing we need to do is to get our values out of percentages and into a more usable form, in this case grams. So for step 1, we need to calculate the ratio of elements to each other. We're going to assume that we have 100 grams of whatever sample we're dealing with, and we're going to convert the percent to grams. And to do that, we can simply drop our percent and replace it with grams as our new unit. Secondly, we need to convert these grams to moles using our molar mass for each element. And then finally, we need to clean up the ratio by dividing all moles by the smallest mole value. So let's take a look at an example. If rubbing alcohol is 60% carbon, 13.4% hydrogen and the rest is oxygen, what is the empirical formula? So step 1 says to calculate the ratio of elements to each other. So the very first thing we need to do is figure out what percent by mass our oxygen is. So we're going to take 100% minus our 60% plus our 13.4%, and we get a percent of 26.6. So oxygen makes up 26.6% of the total mass of rubbing alcohol. So now we're going to assume that we have 100 grams of rubbing alcohol, so we can convert our percentages to grams. So if we have a 100-gram sample and 60% of that is carbon, then we have 60 grams of carbon. If we have a 100-gram sample and 13.4% of that is hydrogen, then we have 13.4 grams of hydrogen. And in our 100-gram sample, 26.6 grams would be oxygen. Next, in step 2, it says to convert grams to moles using molar mass. Remember, in our formulas, all of our subscripts are really mole ratios. So we can't just leave our values in grams. We need to convert them to moles because ultimately we're trying to get those mole ratios in order to form our formulas. So for step 2, all we need to do is set up our conversion factors using our molar masses for each of our elements. So carbon, we're going to multiply by 1 mole over 12 grams to get 5 moles of carbon. For hydrogen, we're going to multiply by 1 mole over 1 gram to get our 13.4 moles of hydrogen. And for oxygen, we're going to multiply by our conversion factor of 1 mole over 16 grams of oxygen to get 1.67 moles of oxygen. So now at this point, we actually have our empirical formula, which is C5H13.4 O 1.67, because we have our mole ratios between all of our elements. But we can't have decimals in our ratios. So for step 3, we need to clean up the ratio by dividing all of our moles by the smallest mole value, which in this case is 1.67. So we're going to divide everything by 1.67. So for carbon, it's going to be 5 divided by 1.67. For hydrogen, it's going to be 13.4 divided by 1.67. And for oxygen, it's going to be 1.67 divided by 1.67. And when we carry this all out, our carbon becomes 3. 5 divided by 1.67 is 3. Hydrogen, 13.4 divided by 1.67 is 8. And for oxygen, 1.67 divided by 1.67 is 1. So we've satisfactorily cleaned up our ratio and gotten rid of those decimals. And now we're left with our empirical formula, which is C3H8O1. This concludes our discussion of molecular and empirical formulas. Bring any questions you have with you to class.